Assalamualaikum warahmatullahi wabarakatuh. Let's learn about string. Guitar is one type of musical instrument that is the way to play it is picked. If the string on the guitar had never been picked, then we will never be able to hear the beautiful sound of guitar. When the guitar strings are picked, the wave generated by the vibration of the guitar string will enter the hole in the guitar and will produce a sound. And now, we will learn more about the concept of the string.
Strings can be found in principle on the guitar strings. When we pick the guitar strings, then a wave called a standing wave. In standing waves, there are two terms. The first is note, and the second is antinote. The note is point that never vibrates at all, but antinote is the point that vibrates with the greatest amplitude. The fundamental harmonic. Now we will analyze the waves in the simple string. Make this is a string. Then when we pick it, then we tie the two ends tightly. The string tie never vibrates because it never vibrates, so we call notes. But maybe the waves don't all notes. The part that rises in the middle is called the antinote. So the simple wave on the string consists of two notes and one antinote. Because the simple is the harmonic that appears, we call the fundamental of harmonic, and we give the number n is 0. Then how many waves appear? Remember, one wave consists of crease and one throw, or one peak and one fillet. The crease is similar to the antinotes of the guitar string, so it can be concluded that it only consists of one crease. So the fundamental of harmonic along the string consists of L equal to 1/2 lambda. The first harmonic. Now the tone or harmonic is higher than the bass, and the wave is a little more complicated, but the principle is the same. This is a string, and this is the bone end. Because the bone must not vibrate, it can be called by note. Now consider the picture. In the middle, because it doesn't vibrate too, it can be called a note. So the wave consists in the picture is 3 notes and 2 antinotes. The part this is expanding now is also increasing, so this wave shows the tone or harmonic that is one level higher than the fundamental harmonic, so we call the first harmonic, and we give the number n is 1. And now What is the wavelength? It is similar to the one wave. So L equal to lambda, or 2 per 2 lambda. The second harmonic. This is a string. In this picture, the tone or harmonic is one level higher. The number of notes increase, and the number of antinodes also increases. So from the picture consists of 4 notes is 4, and 4 antinodes become 3. Because one level is higher, then it is called second harmonic, and this is the second top harmonic. Then we give the number and is 2. What is the wavelength? If we observe this picture, we can see this picture consists of one wave plus 1 per 2 lambda. It is means L equal to 3 per 2 lambda. Let's see how to determine the number of notes, antinodes, and wavelength. To determine the antinodes, please consider the following pattern. If the number is 0, the antinodes is 1. And if the number is 1, the antinodes is 2, and if the number is 2, the antinodes becomes 3. We can conclude that if the number is 3, so the antinodes is 4, and if the number is 1000, the antinodes become 1001. So how about the number of antinodes in point X? Pay attention. Every time when one note rises, the number of antinodes always increases by 1. So, it can be concluded that the formula of the antinodes at point X is n plus 1. To determine the notes, please consider the following pattern. If the number is 0, the notes is 2, and if the number is 1, the notes become 3, and if the number is 2, the notes become 4. And we can conclude if the number is 3, the notes is 5, and if the number is 1000, so the notes is 1002. So how about the number of notes in point X? Pay attention the following pattern. When one number of harmonic rises, the number of notes always increases by 2. So it can be concluded that the formula for finding notes at point X is n plus 2. To determine the wavelength, Please consider the following pattern. If the number is 0, the wavelength is 1/2 lambda. If the number is 1, the wavelength is 2/2 lambda. And if the number is 2, the wavelength is 3/2 lambda. Pay attention in the number of harmonic enumerators. When one number of harmonic rises, the number of numerator always increases by 1. But the denominator does not change, which is fixed too. So it can be concluded that the formula for finding wavelength is L equal to n plus 1/2 times lambda. If we look at L or wavelength, the pattern of number is sequential, namely 1, 2, and 3. By comparing the frequency, then the following pattern will appear.
Exercise. A string have length 100 cm vibrates in first harmonic with a frequency of 400 Hz. Determine A. The wavelength in string. B. The wave velocity in string. C. The frequency of fundamental harmonic in string. And D. The frequency of second harmonic in string. That we know about the length of string is 100 centimeters, and the frequency of first harmonic is 400 Hz. What is asked about? A. Wavelength. B. Wave velocity. C. Frequency of fundamental harmonic. D. Frequency of second harmonic. For the first, we can count the wavelength, use this formula. For count the wavelength, the formula change became this. Lambda equal to 2L divided by n plus 1. We can input the length with 100 centimeters and the n is 1 because the first harmonic. So the wavelength is 100 centimeters or 1 meter. And the next, B. What about the wave velocity? For count the wave velocity, we can use this formula. Velocity equal to lambda times frequency. That we know the value of lambda is 1 meter and the frequency is 400. So the velocity is 100 meter per second. And the next C. For the theory that we know the comparison about frequency of fundamental harmonic with first harmonic and second harmonic is 1 to 2 to 3. So if we count the frequency of fundamental harmonic, it gets 1 part, and for the first harmonic get 2 part. So if we count the frequency of fundamental harmonic is half of frequency of the first harmonic. So the frequency of fundamental harmonic is 200 Hz. And then D. For count the frequency of second harmonic, we can use the same comparison. But in the frequency of second harmonic get 3 parts. So From the frequency of fundamental harmonic is 1 divided by 3, we can count the frequency of second harmonic with 3 times 200 Hz. 200 Hz is the frequency of fundamental harmonic. So the frequency of second harmonic is 600 Hz.
Okay, that's all about string. Hopefully it can be useful. See you on the next video. Thank you for watching.